Hello, my name is Dana, and I'm in group 3. Our project is about detecting heart disease in people using machine learning. And yes, heart disease nowadays is a common disease, and people died from it. Yes, and this statistics find that some of these deaths can be prevented if they're earlier detected, and people really do what is required of them according to the results that we've got. So our project is going to be able to help people to detect that they're at risk of getting heart disease or they're having heart disease or not. So I will start by talking about machine learning. Machine learning is a branch of AI that helps computers to learn to perform functions without explicitly being programmed, but rather learn from the data. Yeah, they learn from the data sets through experiences and creating patterns through them. So there are different types of machine learning, and that's supervised, unsupervised, and reinforcement learning. Supervised data deals with labeled data. For example, in our project, yes, I'm just going to talk about it. I'm not going to follow the slides since they're kind of long, but according to the understanding I have, I'm going to just talk about them. Supervised learning is a type of learning where we are using labeled data. For example, an example I'm using our project. It is going to be, sorry about that. For an example in our project, labeled data is going to be, for example, we are using the age. The attributes that we're going to use is going to be age, the sex, high blood pressure or cholesterol levels, and if the person feels chest pain or not. So this is the label that if a person is having these attributes, then those are the labels you're giving the data. The model will be able to just map the data you've input, that's the attributes, what the patient is having, and then it will be able to give out the output. The output should be whether the person is at risk or is not. So that will be how we shall be applying the supervised learning. Then unsupervised is a type of machine learning whereby you just give the model the data, but then it's not labeled or anything, without any supervision, but rather the model, like, it works on this data itself by creating patterns and relationship between this data, and gives you an output. For example, in our project, if we have different data about different patients, it's going to create relationships between, for example, if there's some patients that are having similar symptoms, for example, if they're having high blood pressure, if they're having chest pain, if they're old. So like this model is going to create relationships, create a category of these people, categorize them together and give you an output based on the similarities and the characteristics. So reinforcement learning, it's based on learning from experiences and then making decisions according to the feedback that you're able to give to your algorithm. For example, now going examples of supervised. Now, first of all, like how we're going to apply the significance of machine learning in this project is going to be like what I've really talked about, like categorizing patients' data and then predicting whether they have the disease or not. So we are going to first stage is collecting the data, then extract the variables from the data that I've talked about before you process it. If it's the data is noisy, you have to clean it, and then you split it and into the testing data and then the training data, which will be fed into the classifier, the testing data, to detect whether to give you a result whether the person has the disease or not. The project idea, I've already talked about it and the significance. So supervised learning, I've already talked about it, the definition and how it's going to be applied. So maybe what I can talk about is the types of problems in supervised learning. That's classification problems and regression problems. For classification problems, it's the model classifies data into categories. For example, if we input some data and then the patient is of certain kind of age, if the patient is old, we'll be able to categorize this person in people who are at risk. If it's younger, it will be in the group of people who are not at risk. Yes, and then regression problems. These are problems whereby the model it works on them, and these problems have a continuous range of variables. So this is the illustration. Yeah, it is the same as the one I've talked about above. And then the algorithm that we shall use in supervised, we are going to use decision trees, random forest, and naive Bayes, and then KNN. So briefly, decision trees, they make decisions based on the attribute you have given. For example, is the person old, is the person young, then you group it into a certain category. And then if after that attribute, you're going to maybe consider that the person have high blood pressure, yes or no, then it makes a decision like that until the attributes are done. So for random forest, all the decisions got from the trees, the decision trees are going to be compared, and the one which is going to be the majority of the trees which will be taken as the final. Then for naive Bayes, we are going to use probabilities. Yeah, types of problems I've already talked them about, and how we use that label data is that we're going to use these features that the patient data and label it then like the model will be able to map it to the what? To the output. So unsupervised learning, yes, you're giving the algorithm, the model, unclassified data, and then it's going to classify it. For example, you're giving it different kinds of data about different patients. It's going to select, for example, yeah, this in green if they're having attributes like symptoms like chest pain, and then they're old, and then maybe high blood cholesterol, or if they're young, it is going to work on them and classify them, give you the output. For example, maybe that all those people that we always find out that they're what? They're at risk of getting heart disease or they have heart disease. The algorithms use application, that's how I've talked about it. Yes, algorithms is clustering, which is the same as yeah, what I've talked about, just classifying groups of data according to their features or similarities. Then the dimensionality reduction method is about like just creating the abstract, like reducing on the complexity of the data, and then basing on the similarity of the features, then you represent it by maybe one data point as one instance. That is reducing on the complexity, yeah, abstraction. This, yeah, the types of insights or patterns is patient clusters, grouping them according to certain traits, and dimensionality reduction, I've already talked about it. Is handling labeled unlabeled data. You just feed in the unlabeled data and then to be able to create the output. And then reinforcement learning, yes, the model will be able to learn from feedback when it makes some certain decisions. For example, if you put in the age of a person, if you put in a person with high blood cholesterol level, then this person says they're not at risk of getting, when the model says they're not at risk of getting the heart disease, then it will be penalized because that's not the right output it's supposed to give. And then the next time, when according to the feedback, to give the what? The right output. Yes, that's the same thing. Reinforcement learning just gives out the algorithms, the results. If they're right, we give it feedback, right feedback. It says that if not, if it's penalized, and next time it won't do the same thing. The environment will be the patient data, and then the agent is the model that we are going to create, which will act on the environment, which is the patient data. And then the reward system is, yes, as I've talked about, is about giving the positive reward or penalty. It will be used in decision-making processes when, for example, in the decision trees, to decide whether this person is at risk or not. Optimizing the problem, like accurately, accurately detecting or concluding or giving a result that this person is likely to have heart disease or not. Then comparative analysis, supervised learning, it can be used. They all can be used, yes, according to the kind of data you have and what you want, the results you want. So for supervised learning, since we have the labeled data, yes, it is really important. We cannot use supervised learning when we don't have labeled data. For unsupervised learning, to help us in a way that we do not have labels of like the relationships between these people, these patients. So that's how it will be able to create like relationships and the patterns. Then reinforcement for optimality of the results that you're supposed to get. Then the scenarios, yes, they're used in hospitals and healthcare centers and personnel to what? To help people to detect the presence of the disease. Then the challenges can be the data quality, whether this data is noisy or inaccurate or incomplete. So that's how it's going to help us. Then computational resources, if you're working on large data sets of data, this project really uses a large amounts of data. And then in the challenge also, like how are these models going to what? To interpret the data. Then mitigating these problems about the data quality, always update the data and like cleaning the data, then using cloud computing scalability on large data sets, and then like regular training these models to give appropriate and right results. Then all the biases that are written here, that they can be mitigated through really having an open mind. For example, working on these projects, if you don't interact with patients, I know what they really go through is something that can really cause issues. Then security, coming up with security measures. Then all in all, machine learning is going to help us in modeling this project for supervised and unsupervised, making right predictions, and then the relationships and patterns in the data. For the challenges and the data quality, the above mitigations, they will it handled like and applied. It's going to be a comprehensive approach in this project, and it will be a success, which will be able to help people in curbing and handling this issue of heart disease. Thank you so much. I'm Diana.